Here we're going to look at question 70 from the IMAT 2011 paper. So in this question we're given 5 different examples of some situations and we're asked which of them is not simple harmonic motion. So if you'd like to have a go at doing this question yourself, then please pause the video now, otherwise we'll have a go at doing it together. So to try and answer this question we need to think about what simple harmonic motion actually is. And basically what it is that we have a restoring force which is always going to act at a rate which is proportional to the displacement of an object from its equilibrium position. So to try and explain what this means, we can use a common example, which is actually given here as option C. And this is a weight moving up and down on a spring. So let's say we have a weight on a spring at equilibrium, and this weight is moved from its equilibrium point and then you let go of it. So the spring is going to pull it back past its equilibrium point, but it'll go too far. And basically the spring will then push it back and forth, so there's going to be this restoring force due to the spring which is moving this weight. And as you can imagine as well, if the weight is really far from its equilibrium point, the spring is going to pull it back with more force, so it's going to be proportional to the displacement. So we know that C is going to be simple harmonic motion, but if we look through the rest, then we can try and work out which of the others are not going to be simple harmonic motion. So there is another common example which is used to explain simple harmonic motion, and that is actually a vibrating string. So in this case, we have a string which is vibrating, and you can imagine that the tension in the spring pulls it back to its equilibrium point, where it's just going to be straight, but pulls it too far so it becomes curved again, at which point it will bend back up and down due to the tension in this spring. So E is once again an example of simple harmonic motion. So next, let's try and consider one of the other options, and let's look at B. This is the ripples from a stone dropped in water. So these ripples are basically just waves in the water, and we've already spoken about waves a bit in the vibrating violin string. So an example of waves is actually going to be another example of simple harmonic motion, since the waves move with the simple harmonic motion. So once again, this case B here is going to be some simple harmonic motion. Next, let's go ahead and look at A, which is the motion of the moon around the Earth as observed from Mars. Well, this one seems quite different from the others, actually, since we seem to be talking about orbits here, and it's quite a confusing situation with the moon around Earth viewed from Mars. But if we were to imagine from Mars seeing the Earth and the moon orbiting around it, then what we would really just see is the moon moving back and forth as it moved around the Earth. So while obviously the orbit is going to be circular from the side from Mars, we would just see the moon swinging back and forth due to the gravitational force from the Earth on the moon and the moon on the Earth. Now this motion would actually be simple harmonic motion, which is not something which is very easy to just sort of see. I suppose you can just imagine it as being the as the moon, moving back and forth across the Earth, but that doesn't necessarily describe it being simple harmonic motion. But to try and prove that would actually be a bit tricky. So it's good to just keep it in mind that this is the sort of thing which is going to be simple harmonic motion. Unfortunately, this is a bit of an odd question, and it is worth just remembering some of these cases in case it's the kind of thing which comes up once again. So with A being simple harmonic motion as well, then we can look at D, and we can try and see that what we'd expect, that this is not going to be simple harmonic motion since the others all are. So while it can be quite tricky to explain why some of the others are simple harmonic motion, hopefully it's a bit easier to see why this is not simple harmonic motion, because actually we have the ball, which would be at equilibrium position when it's on the floor, but all it does is move up and then back down again, up and then back down. It's not as in the other cases where there is an equilibrium position at the centre and the ball moves either side of its equilibrium. Instead it starts at one equilibrium and moves up and down, and there's no sort of constant restoring force, if you like. There is gravity the whole way, and this gravitational force is going to be constant at all times. It's not going to be proportional to the displacement. So hopefully you can see that D is not going to be simple harmonic motion, and so our final answer is just going to be D.